Okay, we're going to finish the section off by looking at some absolute value graphs. So let's get the parent ones in there. So f of x equals x. It's just your line. And we talked about it before, about how the absolute value graph came into being. So just to refresh that, absolute value makes everything positive. So it's taking any y value that was negative and it just makes it positive. So it flips this part of the line, it flips it up, and so that's how you get that V shape. Okay, so part B and D, they're just regular transformation or translations. So this plus 3 means it's getting moved up by 3. The negative out in front of it just means it's going up and down. Or up and down, upside down. So it's an upside down that's hitting 3 up here at the top. And your x-intercepts, if you figure out what makes this whole function equal to 0, that would be negative 3 and 3. Part D, what makes the inside equal to 0, that would be a positive 2. So it's taking the parent function and it's moving to the right by 2. And if x is 0, that means the y value is 2. Okay. Oh. Well. I guess forgot to adjust my numbering here. Anyway, f of x equals x to the third. That's that graph that slides right through the origin. Like that. Well, what if there was absolute value bars stuck on it? Well, the concept is going to be the same as it was when we just did the absolute value of x. Like, the concept is the same on how they came up with this graph. Because again, it takes any negative y value and flips it up to the positive y's. So here's your x to the third. Well, it's taking anything below the x-axis, so this section here, and it flips it up. So it really gives you some sort of skinny parabola. So that's how you can process the absolute value of a curve, because it doesn't matter what it is. If you can draw it without the absolute value bars, then you can draw it with the absolute value bars. So this last one over here in this column, root x minus 1, it's taking the square root graph, which normally starts at 0 and arcs over. It's moving it down by 1. Let's move it down. And then it arcs over. So the x-intercept would be at 1. So I want the absolute value of this function or this graph right here. So it's taking this little piece and it's flipping it over. It's flipping it across the x-axis, but it's keeping, the curvature in the same. It keeps that. You have to keep that the same. Keep that in mind. So it's not doing this. If this was your piece, then below it, it would have had to do something like this. It's curving the other direction. So when you flip this piece up to the top, it's curving like that. So it still hits at the 1, and then this part of the graph stays where it is. So just like that again. So that's how you can tackle doing the absolute value of these kind of random functions in there, you can take the bars off and just go, okay, can I graph that? And if your answer is yes, then you would know how to graph with the absolute value bars. If you take the bars off and you don't know how to graph it, then you're kind of out of luck. So moral of the story is know your parent functions, know how they work, because then you should be able to graph something like this. Okay, so that'll do it for section 2.5. So give those homework problems a good old try, and let me know if you have any questions.